Hello everyone. This is going to be a video on the magnetic force on a moving charge. More precisely, it's going to be a video on how to determine the magnitude or the amount of force that acts on a moving charge. And to do that, we're going to use this equation. F equals Q times V times B times the sine of an angle theta. All right, so what does all this mean? Well, a lot of these things we've seen before. F is the magnetic force measured in newtons, just like other forces. Q stands for the moving charge, and it's measured in coulombs, so that should be familiar to you. V is velocity, measured in meters per second. And B is the magnetic field strength. You could also say B is the magnitude of the magnetic field. All right. And it's measured in Tesla. Capital T is a symbol for Tesla, and 1 Tesla equals a kilogram second squared ampere, or a kilogram over coulomb seconds. 1 kilogram per coulomb second. All right, and that's the Tesla in the standard unit. Now, there's some things to know about all of these. It's very important, is that these are all vector quantities. Okay, that means they have a magnitude or an amount and a direction. Okay, all of these except for Q. Q is not a vector quantity. It can be positive or negative, but charge doesn't really have a direction. But force, velocity, and magnetic fields definitely have directions. We can talk about how strong they are or how much of them we have. In other words, we can talk about the magnitude, and we can also talk about their direction. All right. So let's move on to, let's break it down a little more. I want to focus now on just this part of the equation, B sine theta, and talk about what that means physically. That's a mathematical description of something physical, and I want to talk about what that is. All right, so B times the sine of theta. Well, theta is the angle between B and V, between the magnetic field and the velocity vector, the velocity of the charge. So let's use the coordinate plane to the left. Let's say that I have a charge at the origin. Let's just put it at the origin. That's going to make it the simplest. We'll say it's positive. Why not? And let's say that that charge is moving to the right with some velocity v. I don't know, 10 meters per second. Not that it matters too much how fast, but it's moving to the right. And let's say that we're near a magnet and it's got a magnetic field, and at this point the magnetic field is just is up. All right. In this case, the angle between B and V is 90 degrees, and B sine of 90 degrees is going to be B times 1. The sine of 90 degrees is 1. This is when this is the angle that maximizes the force on the charge. If the angle is less than 90, let's say that we had B here at an angle of maybe 70 degrees. Let's calculate that real quick. Sine of 70 degrees that will be roughly B times 0.9. So there, only 90% of the magnetic field exerts a force on the charge. Okay, and if B is parallel and the angle is 0, then the force will be 0. B times the sine of 0 degrees equals 0, and there'll be no force on the charge. Okay, so the overall point here is it doesn't matter what B is. What matters is what is the component of B that's actually perpendicular to the velocity. That's all that matters. So if you have B at some angle like this, we don't care about the full value of B there. We only care about B sine theta, which is that B sine of theta gives you the component of B that's perpendicular to the velocity. And that's the component that exerts a force on the charge. Okay, so that is what B sine of theta does. It gets us that perpendicular component. The component that's perpendicular to the velocity. That's what determines the amount of force acting on the charge. All right, so hopefully this demystifies the equation a little bit. I'm going to do another video on how to determine the direction of this force on a moving charge. So tune in for that. Thanks for watching.